Good morning. Today I would like talking about improving biochar carbon sequestration through biomass chemical modification. Currently, global climate change is a big challenge for us. Climate change is a primary result from natural causes and human activities. Recently, studies indicate human activities are very likely to explain most observed global warming. Global warming is believed caused from large emissions of greenhouse gases, primarily for CO2, carbon dioxide. Climate change will change our life. There are two things I truly realize: the climate change is surrounding us. In Champaign this year, the summer is very good. Not very cold, not very hot, except one thing. Last month, on July 12th, we got 4 to 6 inch rain in few short hours. You know, Champaign, we are not in the flooding zone, but unfortunately, my finished basement got flooded. It was a nightmare that weekend for me. Another proof for climate change is since Industrial Revolution, global average temperature increase with increasing atmospheric CO2 concentration. So the weather becomes hot and hot. The people wear less and less. So we have to stand up to the control the CO2, carbon CO2 emission. So currently, for example, like geological CO2 storage is a very hot area. Big company and government spend millions, billions of dollars to pump the CO2 into the very deep underground. I think the idea very cool, also technique very cool. But the question is, if we can store the carbon in the soil, do we need to go so deep? Biochar provides this the opportunity. So biochar is made from the biomass. I think a major difference between the biochar and other carbons, like charcoal, char, active carbon, or black carbon, is the biochar used for carbon sequestration. How biochar sequesters atmospheric carbon? Let's take a look at this slide. For the natural carbon cycle is neutral. If we pyrolysis to produce biochar from the biomass, we can lock 50% biomass carbon into the biochar. Considering biochar remove circulating CO2 from atmosphere and store in soil for a long time, so the processor is carbon negative. So let's count the carbon footprint. We know the biomass in the soil is readily decomposed after 100 years. No biochar will remain. But if we use the pyrolysis to quantify like 15% biomass carbon in biochar, after 100 years, maybe 40% biomass carbon will stay in the soil. But here a question is during biomass pyrolysis, 50% the biomass carbon will convert to the syngas and the bio-oil. So at that time, compared to the biomass natural decomposition in the beginning, so this look like a carbon net positive. But if we can lock the carbon in the biochar during pyrolysis, we can use less time to starting the biochar negative processor. So this study idea is to using phosphorus leaching chemical, our pacivator-like the material, and to the biomass before pyrolysis. The purpose is using this chemical motivation, biomass chemical motivation, to want to lock the more biomass carbon in the biochar and increase its carbon retention. So this study, we have 6 compounds, have to be tested. This slide shows when 6 chemical additives add to the sawdust. So we when the salt compared to the biochar without any treatment. So all carbon retention for the treated for the modified biochars, the significant increase. So this means that using chemical additive can return more carbon, more biomass carbon in biochar. Similar results for switchgrass. Another 6 chemical additive, we found the TSP have higher tendencies to increase carbon retention. TSP is a trouble superphosphate, is a phosphorus contaminant fertilizer. Because it is a low-cost chemical additive, also it is relatively environment friendly. So we select TSP for the following study. So this slide shows the effect of 2 pyrolysis systems on biochar, the retention in biochar, biochar the carbon retention. So compared to these two is the biomass without the TSP addition. So using the biochar produced for gradient pyrolysis is a little bit higher than the biochar made from lignin pyrolysis. But for these two, for the biomass mixed with the TSP, we didn't use these 2 pyrolysis system. Doesn't show the much difference. So to figure out the action mechanism between the TSP and the biomass during pyrolysis, we conduct XPS analysis. XPS is X-ray photoelectron spectroscopy. From this spectrum, we compare to the unmodified biomass. We find the new peak in here in the TSP modified biochar. This new peak is contribute to this chemical bond formation. Also, we did a XRD analysis. A new peak show up in this compared to this biochar made from the biomass without any chemical addition. We find a new peak for the biochar made from some phosphate treated the biomass. So this peak relate to this carbon phosphorus chemical bond. So this study suggestion, that the TSP, the phosphorus, and the biomass carbon can bond during pyrolysis. That's why we can return more carbon in biomass in biochar. So we know the TSP can increase the carbon retention. But we hope the carbon still stable, because for the carbon sequestration purpose when this biochar used in the soil. So that's why we hope that we made the carbon put in the soil, no degrade, or slightly degrade. But we don't want it like this case. If it degrade very fast, we lost our carbon sequestration purpose. So that's why we test their stability. We use TGA analysis to assess biochar thermochemical stability. The biochar TGA analysis under nitrogen condition reflects its thermal stability. From these two graph results shows the different mass loss between the TSP modified biochar and non-modified biochar derived from this chemical loss. This is a suggestion. Sequence the carbon in TSP modified the biochar and the non-modified biochar. They have similar thermal stability. For the TGA analysis under air atmosphere reflects its oxidation stability compared to the biochar produced from biomass only, the TSP pyrolysis modified biochar need a much higher concentration for the degradation. Suggests this TSP addition could increase biochar oxidation stability. This means use TSP, we can increase the biochar thermochemical stability. Also, we conduct a soil incubation study to monitor the biological mineralization of TSP modified biochar in soil. We did like 3 months. During this 3 months study, we find compared to the soil without any biochar yielding, the biochar with the TSP biochar added to the soil, no significant increase for the CO2 emission. But if you use the biomass without the biopyrolysis direct put in the soil, we can see we can large emission CO2. We can see large CO2 emission compared to the use the biochar. Because based on these results, we used a dual exponential model to calculate the cumulative amounts of the CO2 during this incubation period. Based on this calculate, we estimate for the biochar the carbon footprint in the soil. So we found if we use the biomass direct put in the soil, after 5 years, about only 10% the biomass will remain in the soil. For the biochar, non-modified biochar, maybe 40 to 45% remain in the soil. But use our TSP modified biochar, we can keep 6 to 65 biomass carbon in the soil. You know, TSP is a phosphor-rich the fertilizer. So we conduct a phosphorus leaching experiment. We said compared to TSP only, we found that the biochar, TSP modified biochar, they have less phosphorus leaching. So this is further confirmed because the TSP phosphor can react with the biochar biomass. So they will bond together, so that's why can reduce their leaching. So this gives us another idea. Use this TSP modified biochar. We can use it as a slow release fertilizer. So that's why we need more experiment for this one. Okay, before I give you before closing my talk, I give you a quick review. Currently, climate change is a big challenge for us. It's believed global warming is caused from large emission of greenhouse gases, primarily from CO2, carbon dioxide. Biochar have a good opportunity for the carbon sequestration. So in this study, we add chemical additive to the biomass before pyrolysis. The purpose for this chemical biomass chemical modification, we want to increase more the carbon remaining in the biochar, increase carbon retention. We find that TSP, phosphorus fertilizer, have a high can significantly increase biochar carbon retention. Because the TSP, the phosphate, can be bonded with the biomass carbon, so they'll increase keep the more the biomass carbon in the biochar. We found that the use TSP analysis show the TSP modified biochar. They are thermochemical stable. This means the very chemical stability. Also, when TSP modified biochar applied to the soil, they are very recalcitrant to degradation. So that means they are biological stable. So we found also, we do some carbon footprint analysis. We found the use of TSP modified biochar can keep 6 to 65% biomass carbon in soil. This is much higher than the non-modified biochar. So also we're studying to use the TSP, modified biochar, as a slow-release fertilizer. Finally, I will thank you, my colleague. I will thank you this research. Now I take your question.